All right, here we go. So again, I think the initial part right here is just something good to just go down and review everything. And then tonight you finish up, and then tomorrow we'll come back and go over anything that you don't remember or don't know. All right, but basically this is obviously the, it'll look just like this. All right, it'll be just like this. So here we go. Notice it does not say to use interval notation. It says graph. Everybody's got to know how to graph. So everybody should be able to tell me we're looking at less than -4. So here's -4. Here's 4. You're supposed to tell me it's an open circle, and then we're going to the left. All right. Anybody have any questions? All right, for number 2, x greater than or equal to -2. So I just put -2, 2, solid dot at -2 going to the right. Greater than 3. All right, here we go. 3 and -3. Open circle at 3. And we're heading to the right. I feel like everybody should be pretty good with this. Less than or equal to 2, just to make sure we have -2 and 2, solid dot going to the left. All right, so those were all of the inequalities. All right, those were all the inequalities.
Matter whether the arrow passes like the second number.
No. All right, now we hit absolute value inequalities. So I told you absolute value inequalities. You write it without the absolute value. You write it again, changing the signs. All right. And so now you're just saying I have -6, I have 6. Greater than 6 is an open circle going to the right. Less than -6, open circle going to the left. All right, take a minute to see if you can do number 6. So if I am less than or equal to 3, solid dot going to the left. Greater than or equal to -3, solid dot going to the right. So in this case, it would just be pretty much everything in between. All right, -3 and 3. Of course, it's a solid dot. All right. Now let's take a look at absolute value of x is greater than or equal to 4. So we're writing it x greater than or equal to 4, x less than or equal to -4. Again, I like to put the answers down. -4, 4, greater than or equal to, less than or equal to. Now again, remember, those are solid dots. All right, any questions? Well,
You've said not to worry about the graph. Even if it does, if we don't have to do the graph to solve it on the test, we don't.
this direction say graph them.
All right.
All right, number 8. X less than 7. X greater than -7. All right, so once again, we're just doing -7, 7, greater than -7, less than 7, So again, it looks like we're just graphing everything what? Everything in between. Okay, so now we're reviewing interval notation. No. All right. Writing them in interval notation. All right. X is less than -12. Now, at this stage, after we have done them so much, you ought to be able to say in your brain, if I'm less than -12, because we read numbers from left to right, all the numbers that are less than -12 are going to be written as -infinity to -12 with parentheses. All right. That's it. If there's any doubt whatsoever, just put the number line down. All right. If you put the number line down and recall that over here is -infinity and here is infinity, and here is -12, open circle going to the left, there you have it. All right. I used to tell my kids it's just an abbreviated number line. That's all it is. All right. So now I would hope everyone will say, okay, X is greater than or equal to 6. If X is greater than or equal to 6, that means okay, Oliver. You're starting at 6 and you're going to infinity. All right. There is a bracket at 6, parentheses, infinity. Anybody have any questions with that? Anybody? Okay, now I have X greater than -1. Again, X is greater than -1. So I'm starting at -1 and heading out to infinity. That's how easy. Now, if I'm less than or equal to 13, again, think about small to large. We're at -infinity to 13. Bracket on 13, parentheses on the -infinity. Any issues? The reason why I'm making sure these are correct is because if these are correct, then as you go down the page, all of those should be what? They should be correct because now you know how to do it. All right, you just have to make sure you do your algebra correctly. All right. Now, again, for graphing X is greater than 2. For those of you guys who like to remember things, this is an or statement. Greater than is your or statement, which means they're going in opposite directions. So I would like for you to write it as X is greater than 2 or X is less than -2. How did I know it was an or statement? Because you can't be greater than 2 and what? Less than -2. That wouldn't make sense. All right. So again, on your number line, if you need to, let's just say you need it. Here's -2, here's 2, greater than, and that's less than. All right. So if you need a number line, sometimes it's helpful if you get a little confused. All right. But your answer then, you have to remember this is -infinity, this is infinity. We're going from -infinity to -2, union to infinity. Wilson, what?
So just like for that, it's so if it's an absolute value, it's an or, if it's not an absolute value.
No, I did not say that. Greater than is an or statement. Less than or equal to will be our and statement. All right, but again, I never really had to remember that because I could look at the number line and tell if it was an and or an or based off the direction of the arrows. All right. So here again, you would write it as X is less than or equal to 5. and x is greater than or equal to -5. Anybody have an issue with that? All right, so interval notation. All right, where everything between -5 and 5, where everything between -5 and 5. All right, again, greater than or less than is and.
What about with union then? Cause I thought you would have to do negative infinity to -5,
I'm sorry you thought that.
so how do you tell the difference?
It's greater than -5, Oliver. It's greater than -5 and less than 5. They're not going in opposite directions. What do you mean, what, Oliver? Just draw your number line. Remember, you're confused. So draw a number line. There's -5, there's 5. Greater than or equal to, less than.
I thought that would be an or statement.
I can't help what you thought, Oliver. There's nothing I can do about that. That's not correct. I said less than is an and statement. Isn't that a less than symbol? This is a greater than. All right, here we go. So for number 15, x greater than or equal to 7, or x less than or equal to -7. All right, at this stage, I'd want you to kind of look at that and understand the direction of the arrows. So I'm going from -infinity to -7, union 7 to infinity. All right. Now on number 6, we have less than. All right. So again, write it. X is less than 11. X greater than -11. They do connect. All right. Less than is the and statement. So that means it's everything between -11 and 11. All right. All right, what I want to do now is I want to spend some time with you on 31, 32, 33, and 34. So just skip to those for a second. All right, I kind of was trying to challenge those you guys who understand what's going on. All right. And I'd like everybody just to sit and think of these. All right. And they have a think there for a reason. All right. I want you to think about in your head all the numbers that are greater than 2 or less than 8. Greater than 2 or less than 8. Anybody have a thought for this?
Everything.
That's very smart. That's right. Everything. So your answer would be -infinity to infinity. All right. Now, obviously, the question is, how do we know that, correct? All right. So if you want to, on these, again, I always tell kids it's a good idea to write out the answer. Greater than or equal to 2 is going this way. Less than or equal to 8 is going this direction. All right. Now, does everybody agree? Because it's an or statement, I only have to be true for one of them.
Yeah.
All right. So please look up here on the board. So I try to show kids that I've kind of separated them into how many intervals? 3. I hope you can see I've tried to separate them into 3 intervals. Are any of these numbers in the pink area greater than 2?
No.
No. But are they less than 8?
Yeah.
Because they are less than 8, is it a solution? Yes. So all those are solutions. Look at the green. Is the green greater than 2? So do I have to even say the other part?
No.
No, because it's true for what? One of them. Does everybody agree with this? Now look at the yellow. Is 9 greater than 2? But is it less than 8? Does it matter? No. That's how he knew it was all solutions. That's how he knew it was all solutions. All right, now I'm just telling you, this is a little bit more advanced. All right, this is what I would expect from my Algebra 2 kids to be able to understand that. All right, you're smarter than the average math student. So you should be able to look at that and say, okay, I want to understand numbers better. That's how you understand numbers better. All right, please don't sit and stare at it. So now we're going to go over to the next one. Now, what are the numbers? Come on. This is just thinking. What are the numbers greater than 8 and less than 2?
That also be negative.
So now what I want you to do before you say something and raise your hand and just say the first thing that comes to your mind, probably the first thing that comes to your mind is what? It's probably not right because they're harder. So, Mr. Cappy, give me a number that's greater than 8 and less than 2. Give me a number that's greater than 8 and less than 2. There aren't any. That's what I'm trying to tell you. You got to think through these issues. All right? Not just say the first thing that comes to your mind. The and the or mess kids up. But if you understand what and means, it's not really a problem for you. And means it has to work in both cases. Is any number greater than 8 and less than 2? No. That's why we say it's a what? No solution. All right. Now we're going to think about number 33. All right, everybody look at 33 themselves. And then what I want Charlotte to do is tell me the answer. 2, infinity. You are brilliant. Now, you didn't say anything about. You are amazing. All right, now, please look at this, just to be sure. All right, I have 2 and I have 8. All right, the first thing we're doing is we're going to look at greater than or equal to 2, going in this direction. And then I have greater than 8 is going in this direction. Are there any numbers in the yellow that satisfy those conditions?
No.
No, that's nothing. Anything in the purple region?
Yes.
Yeah, because it's a what?
It's in between two.
It's an or statement. So that works. The area in the green is true for how many of the regions?
All of them.
Both. Right? The purple is true for how many?
One.
1. All right. Now, again, guys, come on. All right. That's how she figured out 2 to infinity. All right. Now, those of you guys who were listening, please just try 34. Try 34. Write down your answer. Then we're going to let Jacob try to tell me an answer. Just give me about 15 more seconds, Jacob. I want you to be ready. You ready?
No, I'm not.
All right. Tell me what you think.
X is greater than or equal to 2 and X is greater than 8. Wouldn't it just be 2 bracket 2 to infinity because it will intersect with the 8?
So what numbers are greater than 2 and greater than 8?
Anything above 8, so be in.
So
8 to infinity.
come on. What I'm not understanding, I'm trying to teach you guys. Slow down. Don't say the first thing that comes to your head, especially when you're at problems that say you got to think a little bit to get it right. All right. I think it's obvious. What numbers are greater than 2 and greater than 8? All the numbers that are what? Greater than 8. 8 to infinity. Are we including 8?
No,
No, we are not. All right, we are not.
like like 2 and then it'd be like 1.
Is 3 greater than 2?
Yeah.
Is 3 greater than 8?
No.
One thing that we don't work.
Therefore, 3 is not a solution. Although 3 is greater than 2, 3 is not greater than 8. Nor does that make sense now? You sure?
Yeah.
All right. Hopefully you listen to me. Hopefully listen. All right. Now I'm going to make one other little suggestion here. Absolute value. How many solutions? 2 equations. That's what you have to write down. 2 equations. Now, the ones before, when it's just a regular inequality, I have kids on the test that write 2 equations for the inequalities and 1 equation for the absolute values,
I'm really confused.
right? So we're not doing that. Make sure you're listening carefully on the numbers from 17 through 26. There's just what? 1. All right. Now everybody look at 26. For some dumb reason, I forgot to change that again. Change that to greater than. Change that to greater than or equal to for me. All right. So everybody's looking right off the bat for 17 through 26. Everybody's with me. Now look at 27 through 30. Those are my compound inequalities where you have to figure out the direction. Then after that, you have your what? Absolute value inequalities in which you have to write what? 2 solutions. All right. So I'm going to give you an example of each, and then I'm going to turn you loose and let you get to work. All right. So here we go. Let's go back to question number, let's do 17. All right. So for question 17, everybody's looking. 4x minus 1 is greater than 8x minus 22. Now, once again, I try to keep the variables positive. So I move minus 4x, and then I add 22. So I have 21 is greater than 4x. Now I divide by 4. So I have 21 over 4 is greater than x. Therefore, x must be less than 21 over 4. If x is less than 21/4, everybody's thinking about less than 21/4, that means we're going from negative infinity to 21 over 4. All right. Anybody have any issues with that? What, Oliver?
Can you do that on the number line?
You can do it on the number line, yes.
I don't know, can you give an example of that?
You're asking me to do an example of less than 21/4.
I'm kind of confused on all of this.
What do you? 21/4. Oliver, really, you need me to draw a number line for you?
I think I get it.
All right, now, just to review, let's look at 19. All right. Whenever you multiply, divide by negative, you have to do what?
It's just,
Change the inequality sign. All right. So let's distribute negative 4x plus 10 minus 4 is less than 18. Could I have added 4? You could have divided by negative 2. Yes.
If you,
Well, you change the sign.
Not yet. I haven't divided.
Oh, you distribute it.
I just distributed. What, Oliver?
if you divided by negative.
I haven't divided by negative 2.
I'm just trying to.
No,
understand.
nope. Negative 4x plus 6 is less than 18.
Where are you getting 6 from?
Shh, shh, shh. Now we're subtracting 6 from both sides. Now, when we divide by negative 4, here is where you change the inequality sign. So x is greater than negative 3. All right, so I'm starting at negative 3 and heading out to infinity. That's what we're doing. All right, all parentheses, because there's no equal to. All right. And if you add 4 and then divide by negative 2, you'll get the same result. You get the same result. All right, so there's 2 examples there. So now I'm going to jump down. Let's jump down to the absolute value inequality. All right, let's take a look at 43. Let's take a look at 43. Isolate, everybody needs to make sure you remember this. You must isolate the absolute value first. To isolate the absolute value first, you'd have to subtract 5. Subtract 5. Negative 4, absolute value, x minus 3, less than or equal to negative 20.
And then put the sign on this.
Flip the sign when you divide by negative 4.
Fine.
So now you'll have absolute value of x minus 3 greater than or equal to 5.
Yeah.
No, not yet. Write out both
Oh, yeah.
equations.
Yeah.
Absolute value inequality requires 2 equations. X minus 3 greater than or equal to 5. X minus 3 is less than or equal to negative 5. And now let's take a look at it. Adding 3. Adding 3. Now, hopefully I put a number line there for you, just in case. But hopefully you're looking at it saying, well, if I'm less than negative 2, greater than or equal to 8, that means I'm heading in opposite directions. All right. So then you're going from negative infinity to negative 2, bracket, union, bracket, 8 to infinity. All right, honestly, that's as hard as it gets as far as solving the absolute value inequalities. All right, I'm going to do one more, and I'm going to do a greater than. All right, a greater than 1. Or actually a less than 1. This one started out less than, but the sign changed. Okay, so let's do, oh, I like this one, 46. Everybody take a look at 46. First thing we need to do is subtract 8. So negative 3, absolute value, 4x minus 7, greater than negative 12. Dividing by negative 3 causes what? Yes, absolute value of 4x minus 7 is less than 4. Now remember, you're doing absolute value inequalities, which means you need 2 parts. Absolute value sign. So 4x minus 7 is less than 4. Then you write 4x minus 7
Great.
is greater than -4. All right.
4x minus 7 is less than 4.
So now when I add 7, divide by 4, add 7.
Why did the line under the first,
What did I put a line under what?
under the, less than sign?
Oh, I didn't.
Um,
Oh,
Thank you.
wait a second.
Wouldn't they like each other? Which is the other one?
No, less than 11/4 and greater than 3/4. They're running towards each other, right?
Yeah.
So you would say from 3/4 to 11/4. I know I said. No, it's 11, right?
Yeah. Yeah. Can you say 0.75 to 1.75?
Well, not 1.75, but 2.75.
Yeah.
0.75 to 2.75. Go with that. All right, now, my opinion now is I really think you should go ahead and do the odds, do all the odds first, and then start on the evens. All right, do the odds and then start on the evens.
Then